subscribe. Swipe up, subscribe. All right. So, hey, homework away. Notes out. Let's go. So, where did it go? Yesterday, guys, listen please. Right, computer should be away at this point. Should just have our note packet out, ready to go. So, yesterday, aka Friday, you guys learned how to do the product property. You talked about quotient property, because you all watched my video, right? We saw that the product property works. Square root of 5 times square root of 10 is the same as the square root of 50. We want to know, is that true for addition? If I have the square root of 5 plus the square root of 10, is that the same as the square root of 15? You guys all have calculators, right? Try them. Go. Grab them calculators out. Try it. Let's see what you get. When you get an answer, it's different. No. When you get an answer for square root of 15, one of the more things. What's the point?
Hey, wait, they're the exact same.
No, they're different.
No, they're exact same.
Let me see your calculator.
Hold on, I'm sorry. Yeah, they are.
I'm questioning myself.
Yay! They're the exact same. I put mine in two different ones. They're the same number, right?
No, we're the same.
Hold on, hey guys, look at. Sorry. Alright. Hey, do the same thing.
Yes. No, you literally just. You literally I
No.
thought you were asking if we got the same thing that she did.
Okay, you got the same thing as I'm
Yes.
good. You should. You do not get the same thing when you do square root of 5 plus square root of 10.
Christina.
And the square root of 15, right? Those are not the same. So that addition is not true. It does not hold. This property does not work. It works for multiplication, does not work for addition. However, we are going to figure out how we do add them. Step 1. You're going to simplify each radical as much as possible. That's what you learned how to do on Friday. Right? Simplify the radicals as much as you can. Step 2. Step 2. Then we can add or subtract coefficients of terms that have the same square root. Right? So simplify each radical and add or subtract coefficients of things that share the same square root. It's just like if you're adding with variables. Right? You can only add like terms, things with the same variable, m and m. 7m minus 2m, we do 7 minus 2 is 5m. Right? Same thing with radicals. It must be the exact same under the radical for us to be able to add or subtract it. So it's 3 square roots of 6 plus 5 square roots of 6.
8.
We add the coefficients because the bases are the same here. 8 square roots of 6. So it's just like thinking about variables. If they both have x, you can add or subtract them. If they both have m, you can add or subtract them. If they both have square root of 12, you can add or subtract them. Things like that, where if they have that same square root, you can add or subtract them. Alright, so let's try some problems. Example 1 was super easy. Example 2 is a little more difficult. Square root of 11 plus square root of 44. Can I add those?
No.
No.
Wait.
So what am I going to do?
I don't know.
Figure out a way to solve the problem.
Well, hey, guys. What was step 1? What did we just write down?
Use the product property.
Simplify each radical. Can I simplify square root of 11 at all?
No.
No, it's going to stay the same.
4 and 11.
But I can take a perfect square root out of 44.
You
Right? Square root of 4, square root of 11. Square root of 4 is 2 square roots of 11. Alright? Can I don't know why it writes like that. That's weird. Can I add those now?
Yeah.
Yeah, they both have square root of 11.
211.
What's in front of this square root of 11? 1, right? Just like if it was just x, it'd be 1x. It's 1 square root of 11. So if I add them, 1 plus 2 will give me 3 square roots of 11.
Whoa.
That's my final answer.
I got 10.
Alright? Let's try the third one. Perform the indicated operation. Answer must be exact. Square root of 12 minus square root of 42. Well, square root of 2, can I take a perfect, or square root of 12, can I take a perfect square out of there?
Yeah.
Yeah,
The
4.
one you said.
Square root of 4, square root of 3 becomes 2 square roots of 3. Minus, what about 42? Perfect square that goes into 42.
16.
No, that can't.
4.
No, that can't be there. None.
There isn't any, so can I simplify it?
No.
No, so it stays square root of 42 the whole time.
No.
Can I subtract that?
No.
No, so that's my answer. That's as simplified as it gets.
No, that's kind of weird.
You need to make sure though you are simplifying your radicals as much as possible. Right, if you just leave it at square root of 12 minus square root of 42, that's wrong. Simplify your radicals first, and then see if you can add or subtract. Alright, try the next two. Try the next two, please. Examples 4 and 5.
Oh my God.
Sheesh.
Oh, man. No, 3. 4, 3. Would you get to the second?
You might be, but
You don't understand anything, right? Ooh, 25.
is there anyone that wants to put example 4 on the board? What about example 5?
Where's that?
She just said not. No.
You can check your answers and you put it up there.
Where's the one?
No? Nobody?
What happened?
Yeah, come on up.
Wait, what happened? What happened?
Perfect. Yes.
Yes.
What's math? Wait, no, I'm returning. Wait, how do you do it? How do you do it? Oh! I see now. I do this. I did have it.
Hey guys, you should be checking your answer if she doesn't work.
I told you 93.
Alright, sweet. Yo, check your answers please. Should have got 3 square roots of 2 minus square root of 5. And you should have got 14 square roots of 3. Any questions on those?
No, thank you.
We all got them?
Sadly, yes.
Questions, comments, concerns? Okay,
We could.
our next problem. Find the area and perimeter of the rectangle. Find the area and perimeter of the rectangle. Alright, first things first, we gotta find perimeter. How do we find the perimeter?
Add this on.
Add what?
All the sides together.
But I only have 2 sides.
But it
No, you have to add the other.
It's a rectangle actually.
So, what are you saying about the sides?
They're the same.
So,
Opposite sides.
this is 2 square roots of 10.
No. Other way.
Obviously
Other
what we
way.
meant. Come on, dude.
Opposite sides in a rectangle are congruent, right? So this is 2 square roots of 10, this is 2 square roots of 10. This is 3 square roots of 15, that's 3 square roots of 15. So we need to add all of our sides to get our perimeter. 2 square roots of 10 plus 2 square roots of 10 plus 3 square roots of 15 plus 3 square roots of 15. Alright, first thing when we add, we need to make sure if we can simplify, we do that. Can I simplify any of those radicals? I can't simplify the radicals, but I can add like terms, right? 2 square roots of 10 plus 2 square roots of 10 will give me 4 square roots of 10. Plus 3 square roots of 15 plus 3 square roots of 15 is 6 square roots of 15. Can I do anything else to that?
I don't think so. Do some sort of box.
I cannot, so that's my final answer. Alright. Area of a rectangle.
Multiplication.
What am I multiplying?
The numbers.
Okay, so 2 square roots of 10 times 2 square roots of 10
No,
times
no.
3 square roots of 15.
No, the two right there.
The 2 right here, 2 square roots of 10, 2 square roots of 10.
No, other one.
3 square roots of 15, 3 square roots of 15.
No, come on.
What is the area formula for a rectangle?
They're scary.
Length times width.
Length times width. Thank you.
That's what I was implying.
Length times width.
How
So, 2 square roots of 10 times 3 square roots of 15. If I do that multiplication, Haley, what do I get? If I multiply those two things? A big number. Like what kind of big number?
Big boy number.
Like, shh. I'm asking Haley. 6 square root 150, right? We multiply the whole numbers. We multiply what's under the radicals. Sweet. Final answer?
No. Gotta simplify.
Simplify the 150. So 6 times the square root of 25 times the square root of 6. I get 6 times 5 square roots of 6, or 30 root 6. That's my final answer.
Would you mark it wrong if you just put 6 times 5?
Yes.
You say A equals and P equals. Yeah, because
No,
Oh, because you got.
I have the labels on top. Don't worry.
We don't have.
Okay. All right. Guys, any questions on that? Nope. 3 problems left. The sum of square root of 50 and x squared to 2 is 8 square root of 2. Find x.
What?
Well, square root of 50, the sum means I'm adding, so square root of 50 plus x squared to 2 means equals 8 square root to 2. Well, I can't add 50 and 2.
You sure?
Nope. What do I do?
Simplify.
Simplify 50, right?
25, you sure?
I can take the square root of 25 times the square root of 2, which is 5 square root of 2, plus x squared to 2 equals 8 square root of 2.
X equals 2.
So 5 plus 1 will give us 8.
Ooh, I think I know what X is.
What? Come on, Cole, spit it out.
Trace.
3. X equals 3. Good.
Sorry, look up Spanish.
Try the next one.
Let's put it down.
Try the next one.
Are you just gonna show them it? Or they're gonna make them wait?
When you finish yours, check mine.
Who's that? I know it's 4. I know it's 4.
How did we do?
Ooh, I got the. Oh.
We got it? Everyone got it?
Yeah, yeah.
Flip your page. You got 30 seconds to look at the next problem. We're going to take a vote.
Can I do it?
Nope. Hey, quit shouting out answers.
Stop
Thank you.
cheating. Stop using recaps.
It is, what? I don't know why. Cole, he's lying. Square this number.
Why would I lie?
What am I
Can I see
doing?
it?
A lot?
Wait, can I see it?
10 seconds left.
Squaring a number right now.
It's numbers.
Cubing it.
Don't shout it out.
Jared, can you grab me a Kleenex?
All right, here we go. Yo. Guys, hey. How many people think it is 1?
No
How many people think it's 2?
No one.
How many people think it's 3?
No one.
How many people think Jared should stop talking? Thank you. All right, awesome. How many people think it's 4? You are correct, right? Why is it 4, Miss Wick? You can't add what's under the radical, right? We found that out at the start of the lesson. Good. Any questions on what we did today? Cool.